Here again, we'll look at constructing a confidence interval when we're comparing the mean between two groups. And it'll follow the same structure that it did before. Notice we'll just kind of adjust our formula a little bit here to fit the means, right? So here we're constructing a confidence interval to tell us something about the difference between mu1 and mu2, and it's using the point estimate x1 bar minus x2 bar, so looking at the difference between the two samples. And in this case, our margin of error, again, was computed using the t-score for the critical value and the standard deviation of the combined samples. So what I'll do in the next example, though, is I'll rely on our 2samp t-int formula. So it's like 2samp t-test, but now this is int, so it's computing the confidence interval. And it'll ask for just the basic data from the sample, their sample means, the sample standard deviations, and their sample sizes, and then a confidence level, and then it'll go through the work to construct the confidence interval for us. But here, let's rely on our calculator to do all this formulation for us. The Gallup organization wanted to investigate the time that American men and women spend hanging out with their friends. A random sample of 700 men surveyed spent a mean time of 10 hours per week with their friends with a standard deviation of 1.9 hours. On the other hand, 740 women surveyed spent a mean time of 7.5 hours with a standard deviation of 1.6 hours. Construct a 95% confidence interval estimate for the difference between the corresponding population means. So our point estimate will just be x1 bar minus x2 bar. And let's specify exactly what these two groups are. So let's let mu1 equal to the mean amount of time that men spend with their friends. And then we'll let mu2 be the mean time that women spend with friends. Okay. And so our point estimate here will be subtracting the mean between the two samples. So we had in one sample, here this first sample, in this case we had 700 men surveyed, so that's the sample size of our first group. And they spent a mean time of 10 hours per week, so that'll be x bar 1. And their standard deviation was 1.9 hours, so that's S1. And then for the sample of women, we had 740 women, so that's N2, with a mean time of 7.5 hours, so that's X bar 2. And the standard deviation of 1.6 hours, so that would be S2. And we're going to construct a 95% confidence interval. Okay, so we know how to construct the critical value, T alpha over 2. In this case, it's a 95% confidence level. So alpha would be 1 minus 0.95. And so alpha over 2 would be 0.025. So T of 0.025 would be the region here that has an area of 0.2025 to the right of it. So we're looking for the part that has an area of 0.025 to the right of it. So you can use inverse t, since we're using t-scores to calculate that value. And in this case, because we're looking at combined samples, our degrees of freedom will be computed a little bit differently here. But anyways, you guys can remind ourselves how to find the degrees of freedom, in this case when we're combining the samples. But what I'm going to do is actually compute this value on our calculator. So in the next slide, I'm going to enter this data into our calculator function. So on the previous slide, I stopped short of computing t alpha over 2 because, well, I didn't want to go off onto a tangent about the complicated way of computing the degrees of freedom when we're combining two samples. Now, in this case, we can then skip the part about finding a margin of error using that formula, and we can just go straight to constructing the confidence interval using 2SAMP_TInt. Right? And so essentially our calculator will do all the work for us, and we don't have to bother finding the margin of error separately. We can just compute the interval and then figure out the margin of error ourselves if we really need it. So if you recall, we had all the data there in the previous slide. So when we go to 2SAMP_TInt, right, make sure you're doing the interval, not the test, because we're constructing a confidence interval. We're going to enter the statistics here. So looking back at the previous slide, if you recall, for x1, the mean of the first group was 10 hours for the group of men. Their standard deviation was 1.9 hours, and their sample size was 700. For x2, the women had a mean of 7.5 hours, a standard deviation of 1.6, and a sample size of 740. Okay, and in this case we have a confidence level of 0.95. Okay, so once we enter all the data from the previous slide, we get a confidence interval 2.3179 on the lower end up to 2.6821 on the upper end. And yeah, if you notice, the degrees of freedom is given there, so if we needed to use that, we can use it now. It's computed the degrees of freedom now, although it's kind of late in this case because we've already constructed the confidence interval. We don't really need that t alpha over 2 anymore. But with this confidence interval, let's try and make a claim. So what we've shown here is that the difference between mu1 and mu2 is going to be somewhere in between 2.3179 on the lower end, 2.6821 on the upper end. So does it appear that there's a difference between men and women? Well, it's certainly, because the difference between mu1 and mu2 is always going to be a positive value. It's well above 0 here. So that means that mu1 is always going to be greater than mu2. So in general, what this shows is that men spend more time with their friends than women. Okay, and in this case we're using a confidence interval rather than a hypothesis test to draw a conclusion.